Hello, my name is Hector Castillo, and this is my video for Project 2 for Fluid Mechanics with Professor Ozbay, Summer 2026 at UCF. Like it. Up geometry, right click geometry, then go to New Design Modeler. Once on geometry, just click on Z axis to go normal to the Z. And then on sketching, just create a rectangle. Dimension the rectangle. Height at 0.5 meters. Length as 1. Next, click on Concept, Surface from Sketches, Box Select, select the sketch, and click Generate. And that's it for the geometry section. Out of it. Back to the workbench. The mesh. Double click on mesh. So the first mesh we're going to do is a face mesh. Just right click mesh, insert, select face meshing, select the face of the rectangle, apply geometry. Next, we're going to sizing, mesh, edge, control, top and bottom edges, apply, change the type to number of divisions. For this edge sizing mesh, the number of divisions is going to be, I'm using 50. Capture curvature, click no, and change the behavior to hard. Generate. Now we're going to include another sizing mesh, control, click this edge, apply. For divisions, this one I'm going to put 60. Capture curvature no, behavior saw hard. This mesh we're going to include a bias. Just click the first selection and I'm going to be using a factor of 70. Generate. Okay. One last sizing mesh. This time we're going to select the right edge, apply again. Number of divisions 60 to no. Change the behavior from soft to hard. This one will also have a bias. factor of 70 again. This time I'm going to have a reverse bias, so click reverse bias, control, click that same edge, click apply, generate. So this is what the mesh should now look like. We are simulating a flat plate. Very, very small. So the next thing we're going to do is we're going to name edges. So geometry to name the edges, I'm just going to right click, create name selection. For the upper or the top edge, we are going to name this bare bar, excuse me, field. Left, right click, and the outlet, bottom edge, flat plate. To check you have it, you can expand the name selections, click on them, it'll highlight which ones are named. And that is it for the meshing portion. So just go back to the workbench, update your mesh. So we're gonna go up to go into setup, just double click, and then click double precision. Start. So for this portion of the project, the goal is to find the drag coefficient of the flat plate. That will basically be done in this portion. There you go, you see on the right side the mesh. We have the flat plate here, and this is mostly just the far field. This is the focus. So first thing we're gonna do is make sure we are airflow. So go here, model, viscous, edit, right click, edit, and then change it to laminar. And then another thing is changing the residuals. Just gonna add another 0. The residuals is pretty much you just have to find which one works for you. Next, materials, fluid. We're going to change the properties. We're working with air, but we want specific density and viscosity for the problem. So for this, I'll be using 1.2 for the density, and then viscosity is 1.8. Change and create. Close that out, and then just double check. Yep. Next thing, we're going to ensure that the fluid we're using, the and it is, so next we're going to go to the boundary conditions. So the inlet, flow comes from. So we're going to be changing the velocity magnitude to 2 because that is what my case uses. Close that outlet. Sure. Nothing should be changed here, just making sure everything's good. Then also far field, change the type, symmetry for the far field, flat plate, share stationary, no slip, nothing else needs to be changed, just make sure these are clicked. And then reference values. The reference values is what ansys will be using to calculate the drag coefficient. So it's going to be computing from the inlet. Reference zone is going to be body. Area. So for me 0.5. Density should be the same. Viscosity should be the same as we put. Depth should be changed to 0.5 because that is the length stays as 1, velocity. Then we're going to add the drag coefficient by going to report definitions, right click, new force report, drag, that, drag. Everything else should stay the same. Oh, yep, drag coefficient. Flat plate, okay. And then it'll appear here. Initialize. Run. Calculation. Number of iterations you can set to whatever number you want. It's not necessarily going to use all the iterations. It's going to stop once it finds what it needs. Setting it to 1,000. Done. So this value, this last value here is the drag, as you see. We go into this. See, it says drag. These are the values. To get a clear number, just go to the drag and click compute. And it'll show up here. The drag is 0.0039 roughly. And that is all you have to do to get the drag coefficient for the flat plate.